Excellent. Okay, so quiz number 2, correct structure or name below, so nomenclature type questions. Always look at find the parent chain, cyclopentanol, so we know there's going to be a 5-membered ring. Alcohol takes priority, so that's number 1. Then from there, you look for the substituents. This is a trimethyl, so if you started with 1, 2, and it could have gone this way, but I went this way. Carbon 1 is the alcohol, also the 1 there. 2, 4, 4, trimethyl, so that's where the methyls would go. 3, propyl. All right, then for B, again, find the parent chain. So you have these things off the nitrogen, you need to find the longest chain of carbons. So in this case, it would be 1, 2, 3, 4. So 1 butanamine, or just butanamine. And then you look what else is off there. Because there's 2 of them, they're 1, 2, 3, 1, 2, 3, they're both propyls. We say NN, indicating both are off the nitrogen. Di, because there's 2, propyl, butamine. Now for this one, you again need to find the longest chain. And you also want to have the lowest numbers possible, the lowest first number possible. So I could have numbered this, so it's an octane for sure. And I could have numbered it such that the numbers start at the left or the right. If I go from the left, it'd be 1, 2, 3, 4. My lowest substituent would be on carbon 4. But if I go from the right, it's 1, 2, 3. So my lowest substituent would be carbon 3 then. So I want to number it this way. I look and see what substituents we have. We have an ethyl, and a 1, 2, 3 propyl. And then to see the numbers, so I know it's a diethyl, because there's 2 of them. 3, 4, diethyl, 5, propyl octane. Right? E before P, that's the way it goes. All right, so for question 2, we're talking about resonance structures. So again, remember the 4 rules of resonance structures. Atoms don't change positions, never break sigma bonds, only move lone pairs of pi bond electrons, and never break a sigma bond, right? And balance your charges. Of course, balance your charges. That's the 4th one, sorry. So what do you need to do here? You have a ring. You see a polar bond, oxygen to carbon. That's a polar pi bond. Electrons go to the oxygen. That breaks the pi bond. So the oxygen now has a negative charge. The carbon that lost electrons has a positive charge. The pi bond in the ring is right next to that carbocation. So those electrons can move there, which leave a plus charge there. And you can keep going, moving these along. So that's the way I was doing it. If you see something that is electron deficient on the ring, you need to push electrons out towards that. Balance your charges. Don't break sigma bonds. Don't move positions. Only move lone pairs or pi bond electrons. That's the key. So just like in the resonance ones, really gotta be careful about the charges. Balancing your charges, where you move arrows, those are really tough ones, but make sure you do those things. Also with this, make sure you answer the questions. A lot of folks didn't read all atoms, so they just did maybe the nitrogen and didn't give me the hybridization states for everything. So sp hybridized is nitrogen has 2 pi bonds. Notice the box, hybridization state. This carbon right here in the triple bond is sp hybridized as well, has 2 pi bonds. And this carbon right here is sp3 hybridized, of course, because it has no pi bonds. So what hybrid orbital is a lone pair located in? This lone pair is located in sp hybrid orbital. That's because when you're sp hybridized, you have 4 hybrid orbitals. 2 of them are p orbitals, and the other 2 are sp orbitals. So one of these orbitals in the nitrogen is an sp orbital, is being used for the sigma bond, and the other one is doesn't make a bond, but it holds the lone pair. So that's where the lone pair is at. And then what hybrid orbitals are making the sigma bond between these atoms? Well, for one, the 2 has to be 2 different types. There has to be 2 hybrid orbitals that are doing it. If you're sp3 hybridized, all you have are sp3 hybrid orbitals. So that's making the sigma bond. And if you're sp hybridized, you use sp hybrid orbitals to make sigma bonds. So those are the 2 hybrid orbitals that are making up that sigma bond there. So for this one, I want you to circle the molecule with the lower boiling point, so less intermolecular forces, right? Less intermolecular forces. So I'd be looking for hydrogen bonding, dipole-dipole, London forces, and or ion-ion, right? So H bonding is by far the most important one, the strongest force. So things that have H bonding will have higher boiling points. So this one doesn't have the ability to H bond with itself, whereas this one does. They have the same number of carbons. A lot of people point out the number of carbons, but that's not that important relative to hydrogen bonding, right? Hydrogen bonding takes precedent over London forces or dipole too. So it's this one because it doesn't have the ability to H bond with itself, right? To hydrogen bond with yourself, you need lone pairs and polar bonds to hydrogen. This has lone pairs, but no polar bonds to hydrogen. All right, so number 7 asks to draw the resonance arrows to form the structure on the right. So here's a structure. I gave you these two things and I asked for arrows. Folks had a really hard time with this, which was surprising. But the biggest thing you have to remember is a lot of people tried to start arrows at plus charges. That happened a lot, right? Draw in the lone pairs always. This lone pair comes here, right? Think about the bonds you need to form, right? You can't. There's nothing here to move, right? There's an empty positive charge, so you need to move the electrons to reform the pi bonds, right? The other big thing that people struggle with, the correct resonance form. A lot of folks said, wait, well, octet with the plus charge is worse than carbon with the plus charge. It is, but the most important rule is the octet rule first. So this is the most stable, or the major resonance structure because everyone has a full octet. Charges do not take precedent over the octet rule. This is a carbocation, doesn't have a full octet. So the biggest things, you move electrons towards plus charge. You move electrons towards it. You never move it from it. There's nothing to move. Only electrons move. Lone pairs and pi bond electrons for resonance. And then the octet rule, of course, right, is the octet rule. Make sure that's going to give you the major resonance structures. That's not about charge. Charge isn't that important. The octet rule is more important than charge.